Expressions describe a value, sometimes by just giving you the value, like the number 4, and sometimes by giving the instructions called operations for how to find the value, like the example 5 times 4 minus 16. If an expression does not contain a variable, then we can perform the operations, that is, follow the instructions, and simplify the expression to a single value. This process is called evaluating. There are two places where students make mistakes in evaluating expressions. First, by not knowing what operations the expression is giving you, and by not knowing in what order to apply those operations. For example, let's look at 24 divided by 2 times quantity 9 plus 3. We have to know what operations are in this expression. Here we see division, multiplication, and addition. But we also have to know what order to apply these operations in. For example, if I divide first and then add and then multiply, I'm going to get 144. However, if I add first and then multiply and then divide, I get 1. So if I apply these operations in different orders, I will get different answers. Because there are different possible answers, mathematicians have agreed on a specific order to follow these instructions in, called the order of operations. You are likely familiar with this from the acronym PEMDAS. Let's begin by looking at grouping functions. These should be done first when evaluating. Most often you will see this as parentheses. For example, 3 plus quantity 5 minus 4. The parentheses tell you to perform the 5 minus 4 operation first. The fraction symbol is also a grouping operator. For example, 9 plus 3 over 8 minus 2 means that we are to do all of the operations on top, the 9 plus 3, then all of the operations on bottom, 8 minus 2, before completing the rest of the evaluation process. If there are multiple operations in the grouping operator inside the parentheses or on the top or bottom of the fraction, follow the order of operations for those operations in the grouping function. After the grouping functions are taken care of, evaluate any exponents or roots. We will learn more about these later on. Next, we will tackle multiplication and division. You must first be able to recognize the many ways of writing these two. Multiplication can be written as an x between numbers. This is confusing because that x can look like a variable and will not often get used in algebra. It can also be written as a dot between two numbers or two values, or it can be written as one number on the outside of a set of parentheses with another value inside the parentheses. Finally, we can also write multiplication as a coefficient, where it is a number written right next to a variable. That indicates that we are to multiply that number in that variable. Division, too, has several ways of being indicated in an expression. You can use a slash, which is also called a virgule or a solidus. Very rarely, you probably won't hear those words again, to be frank. That slash is used very often when writing division on a computer, but not very often by hand. You can also use the obelus, which is the symbol that you are familiar with for division from elementary school, which again will not get used often in algebra. Most often you will see division simply written as a fraction. Multiplication and division are done at the same time, moving from the left to the right, doing whichever comes first. Even though we say multiplication first when listing off the order of operations, multiplication and division happen at the same time. We are now equipped to look back at the example from the beginning of this video, 24 divided by 2 times quantity 9 plus 3, and properly evaluate this. First, we take care of what is in our grouping functions, the parentheses. 9 plus 3 would be 12. Now I have division and multiplication left. Beginning from the left side of the expression, I do whichever comes first, which means I do the division before the multiplication. 24 divided by 2 would be 12. Now I finish off the expression by doing the multiplication operation, 12 times 12, which would be 144. The same idea applies for addition and subtraction. We do them both at the same time. We do not do addition first. Addition and subtraction happen at the same time, starting from the left side of the expression and moving to the right side of the expression. We can now look at a fairly complex example of this and apply what we have learned. Given 4 minus 2 plus 5 times 4 plus 2 over 8, we can now just move through the order of operations to evaluate this expression. We begin by looking for parentheses and grouping functions. And the entire expression is itself one large grouping function in that it is a fraction. So we're going to first evaluate the top portion of the fraction and then evaluate the bottom portion. So we turn our attention to just the top of the fraction. And now we're going to look to apply the order of operations again. For just this part of the expression, we look for any parentheses or grouping functions. And we do see parentheses that include 4 plus 2. So we perform that operation first. 4 plus 2 is 6. Now there are no other parentheses or grouping functions, so I would look to evaluate any exponents or roots, and there are none of those. So I instead move to evaluating any multiplication or division. It turns out there is one multiplication problem, 5 times 6, so we evaluate that to be 30. There is no more multiplication or division, so we now look to attend to addition and subtraction. And I do have multiple of those. I have a subtraction operation and an addition operation, but I move from left to right doing whichever one comes first. So I begin by taking 4 minus 2, which is 2, and then 2, the result of that previous operation, plus 30, which is 32. Now I look to evaluate the bottom portion of the fraction, but there are no operations, it's just a value, so I can leave it as is. And then, now that I have completed that grouping function of the fraction, I can recognize that that fraction is just division, and so I would find that 32 divided by 8 is equal to 4. To recap, evaluating is simplifying an expression with no variables by following the operations, that is instructions, in the expression in the right order.